Morning. Today we're going to work with some single replacement reactions. Have you ever wondered how you know if you put things together if they're going to react or not? Well, today we're going to talk a little bit about that. This is called single replacement reactions using the activity chart. And so what we're going to do today is we're going to see if some of these, well, there's not just single replacement reactions, but we're going to see if we can put these. If we mix sodium bromide with sodium bromide with barium, we'll see if it does react or not. Now, to do this, we're going to need another chart. Of course, we need another chart. And this chart is based on scientific evidence. Chemists over the years have put things together and seen if they react or not. And what they've come up with is a hierarchy of chemicals. The top of the list is the one that reacts the most, and the bottoms are the ones that seem to react the least. So here we go. Here is our activity chart. And so we're going to start over here on the side. Lithium, top of this chart. That means that lithium can replace anything else that is below it on this chart, and you have one of these charts that are located in your Schoology folder. If you're in class, I'm going to pass them out to you, so you do have this chart. It's also in your book, the same exact chart. All right, so as we can see that if we have an equation, the top is the most active, and it will replace things below it. This first part of the chart, these are all cations, so let's look back at what we just did and we'll check out the chart. I'll see how quick I can do this. Okay, so we have sodium and we have barium, right? Now, what I'm looking at are what's going to replace what. Remember, likes replace likes in this. The positive replaces positive, negative replaces negative. So this first section are all positives. And we're going to look right here and we have Na and we have Ba. So we have to check the chart and see which one is higher than the other. Okay, well, here's Na and here's Ba. So Ba is higher on the chart. So Ba is going to be the one that ends up with the anion. Either, let's just go back and look at it. So we have Na and we have Ba. So Ba was higher on the chart. So what happens? Ba is going to replace Na. So what happens? Well, Ba, which is +2, is going to combine with Br, which is -1. Now remember the rule about the subscripts, right? Those subscripts come from the charges. So we have +2, we have -1. We're going to do a little crisscross. We'll put a 2 down here. All right. Now sodium gets replaced, so sodium is kicked out of the compound. All right. Now sodium's not diatomic, so it's fine like that. All right. Now we have to go in balance. So as this goes through, you got to keep up with the same things we've done. Now we're just adding an extra step on the end of this. So we have 2 Brs on the right, 2 Brs on the left, 2 Nas on the left, 2 Nas on the right, and I believe we're done. Okay, let's check out, let's just pick something a little bit further down the list. How about this iron plus aluminum oxide? So what we're looking at, again, is the Fe and the Al. So we'll just go back to our chart. Okay, let me erase that last thing I had there. All right, there's Al right there, and there's Fe. So this time Al is above Fe. Okay, Al is above Fe. Al is above Fe. So that means if Al is above, it's the most active. So Fe cannot replace it. So what we're going to do is we're going to write no reaction. Now let me say one more time. Al was above Fe on the chart. Since Al was above Fe, Fe could not replace the Al. so the compound went unchanged. All right? And so what we're going to do is we're going to write no reaction. There's no reason to balance this because it doesn't react. And we're just going to leave it as it is. All right? All right, let's go to the next section. Negative. Now I just called this the negative section, the anion section, because these are going to be our halogens. And our halogens also go through a single replacement reaction. I think we're just trying to show you, well, it can happen for the negative also. And so what we're going to look at are the same charges. So we're looking at I and Br. Okay, now you're wondering, where is this on the chart? It's not on the same chart. What I've done is I've added a chart below it. So we have I, we have Br. Let's go look at it. Way down on the bottom, there they are, the halogens. It only has the 4 halogens right there. And actually they're the same order as they are on the periodic table, so it's not different. It's not any different. Okay, so I forget what things I had though. Let's check it out here. So we had fluorine on top, chlorine, bromine, and iodine. Okay, so let's go back. All right, we have I and Br. Okay, and if we look at that, I was in the compound and Br was separate. So I was in the compound and Br was separate. Okay, so Br is above I, so Br is going to be the one that ends up in the formula. I hope that makes sense. So I and Br. Oh, I said it backwards. So I is above Br on the chart. Br is above I on the chart. Br is on top, I is on the bottom. It's the same as the periodic table. I'm looking right over there and I can see the table. Okay, so Br is the most active. There. No confusion now. I wrote it down. That's not chort, that's chart. So there is no reaction. Okay, now it didn't react because Br is the most active. It's going to end up in the compound. All right, yeah, you see me cheating here and finding one that does react. Let's look at the next one. So this time we're looking at Br and we're looking at Cl. Okay, and we'll go back and look at our chart. Now if Cl is above Br, it will react. Oh my goodness, Cl is above Br, right? And so since Cl is above Br, the reaction takes place. It's hard to do when I can't see the chart and the formulas at the same time. But this time we said that Cl is above Br, so the reaction will take place. Now watch what we have to do here. This is a very important part. We have Al plus 3, Cl's minus 1, so we do our crisscross, right, each time, 3, plus Br. Now, I always like to check the diatomics, right? In this whole section, because these are the halogens, there's going to be a diatomic. And so what we have to do is we have to put a 2 behind Br because it is diatomic. And remember, the diatomics only have that 2 behind them when they are by themselves. They're just so electronegative that they can't be alone. And so when they're with something else, in this case, like Al's and Cl3 are together, right? Al's with Cl. Cl doesn't need to worry about being diatomic. It's already attached to something else. But when it's all by itself, like this case where Br is by itself, it has to be Br2. Okay, let's get on with the balancing. Let's start with that AlCl3. So we have, oh look, we have 2 and we have a 3. So we're going to go least common multiple. So I'm going to put a 2 here. And that gives me 6 Cl's. I'll put a 3 there. 3 times 2 is 6 Cl's. Now I'm going to go right to the Al's. I have 2 Al's on that side, now 2 Al's on this side. That gives me 6 Brs, so 3 times 2 is 6. Okay, and try those out. Remember, check the chart first. The one that's higher on the chart is the one that's going to be in the compound. Acids. Okay, Now, acids all start with H. What an acid is a compound that has the cation of hydrogen, right? And that's a simplified version right now, but that's what we're going to use. And you'll look here that I put a bunch of different kinds of acids right there. All right, so if it starts with hydrogen plus 1 with another anion, it's probably an acid. There's a few exceptions to that, but for the most part, you can guess it's going to be an acid. Okay, so let's look at the first one. We have Ca and we have HCl. So the acids, when they write about this, they're going to have it on a special section of the chart. So we have to go back to our special chart and shrink it down a little bit. Okay. If you look on the chart, written in words, right here replaces the H in acids. Replaces the H in acids. Replaces the H in acids. And then this bottom section does not. Okay, so the top 3 sections for it to react with an acid has to be in one of the top 3 sections. So if the metals are in the top 3 sections from lead up, it will react with acids. Okay, and it will kick out the H. All right, so let's go back to our chart. Okay, so I'm just going to pick one of these. Ca. Okay, there's Ca. So we find Ca on the chart, and if Ca is above lead, above that top, was in that top 3 sections, it will react, and it's going to be. So let's go look at it here. Ca is way up top. Look at that. Ca is way up top, and it does react with acids. So what do? We go back and we do the single replacement reaction. Okay, now Ca goes with the Cl. Plus 2 minus 1. Crisscross. There's our 2. Plus H. Now, when you see that H, you should think, diatomic, there's another. Remember, there's 7 diatomics. Hydrogen, oxygen, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Right? They're marked on our table in our room. You might want to mark them on your table if you can't remember those. So we need a 2 behind that. Now let's balance. We have 2 Cl's, 2 Cl's, 2 H's, 2 H's, that's balanced. So all these that react are going to have a hydrogen kicked out. That hydrogen's always going to be diatomic. All right? So that shouldn't be too hard. They'll be all that same pattern. If they're below that line, they do not react. And write no reaction. Okay, there's another acid. Okay, reacts with oxygen. So we have a whole special chart, part of the chart that tells us about oxygen. All right, so acids, oxygen, very important in reactions, right? And let's see what this says here. Oh, they don't have it on. Okay, this chart, I forgot, this chart needs updated a little bit. So what we're going to do is take your pencil and we're going to draw a line right here. Now my line will straighten out. Oh, that's pretty straight anyway, but it will straighten out. There we go. And right above AG, okay? And when you get right above AG, those bottom 3 are special. Listen to them. Silver, platinum, and gold. I know what you're thinking. Oh, that's that Christmas song, right? Silver and gold. Well, in this case, we're talking about precious metals. And why are they so precious? I know what you're going to say. Because they're shiny and pretty. That's right. Why are they shiny? Why are they pretty? And the answer is because they do not react with oxygen. All right. And you know what? Everything else does. Yeah. Some react indirectly, blah, blah, blah. But for the most part, those 3 do not react with oxygen and everything else will. Okay? So that means there's just 3, right? Those 3, silver, platinum, and gold. That's easy to remember. Don't react with oxygen. Let's go back to the chart. Or back to the thing. Okay, look. Well, let's do the second one. AU and O2. Right? There's only 3 that don't, I put all 3 of them on here. There's only 3 that don't react, so we can just write no reaction. Okay? Yeah, you're saying, Mr. Arnold, that was the cheap way. You took the easy one. That's right. I deserve it today. All right, water. Now, water's going to be special. Of course, water's going to. Look at all our special things. We talked about just single replacement reactions. We talked about the halogens. We talked about acids. We talked about oxygen. And now we're going to talk about water. And so, does it react with water or doesn't it react with water? The chart has a special section on that, so we'll have to go back and look. Activity chart. Okay, let's start on the top. All right. And I'll put this in. Let's put it in light blue because that seems like a watercolor, right? Replaces the H in H2O. You form a metal hydride in H2. Okay. What this means, and you know I've been doing this, right? This means that it's going to form a hydroxide, a metal hydroxide. That's OH. So let's do Na. So Na plus, when you write it, write HOH, right? Plus minus. And what's going to happen? It's going to replace the H, NaOH. Oh my gosh, I'm out of space. Plus, oops, plus H2. Okay, it needs balance. The diatomic makes us have to balance this thing, so let's put a 2 here. Gives me 2 OHs, 2 NAs. Right, you've seen that one before, right? That was my shortcut to how to balance a hydroxide. This is why. Okay, so that's what happens on the first section. So the first section, they're going to be HOH, and then it replaces one of those H's and becomes the metal hydroxide. Right, make sure that you crisscross. OH is -1. Make sure that you... and sodium was +1, so make sure that you write the charges and get your subscripts that you need. Okay, now the next section. These react differently. They replace all the H's and form a metal oxide. So this case, let's do Mg. Right? OMG. Mg plus water. And I'm writing it H2O this time because it reacts and removes all the hydrogens and forms a metal oxide. A metal oxide means the metal in an oxygen. So Mg plus 2, O minus 2, plus the H gets kicked out. So they react different from where they're on the chart. Hey, that one's already balanced. We don't have to do anything with that. But you have to do the same thing. Write all the formulas correct. Get that diatomic in there. And then you have to balance this thing out. But it's already done. All right? And then as we go down the chart, that's the last of the oxygens. Okay? All right. I believe that's it for weird things. Let's go and see what we've got here. Okay, so on this chart, if it's in the top section, it's going to replace the H of OH, right? And there's one we just did. We did sodium hydroxide, so we had, this was in the top section, NaOH plus H2, and then we had to balance. If it was in the middle section, and one in the middle section would probably be iron here, or the second section, I should say. Let's go back and look. Fe, yep, in that second section. Then it's going to be an oxide. So Fe, I said Fe, yep, here we go. So Fe is going to be, and I haven't wrote, I have an HOH each time, but this case is going to be Fe goes with an O. This was +3, this was -2, crisscross, plus H2 gets kicked out. Second section, this is the pattern you follow. Have to balance this out. There's 3 oxygens. That gives me 6 H's total. 3 times 2 is 6. 2 Fe's. Okay? And then, if it's below that, and look here, we have silver, right? Ag. We know that's in the bottom section. We know that's not in the top 2 sections. We don't have to look at the chart. That's going to be a no reaction. All right? That's it. If you can use that chart, you can figure these out. It's not too bad. Eventually, you get sort of a feel for it. You know which ones are which, where they're at, and it's not that bad. It's just another piece of the puzzle. All right. Have a great day.